Hello and welcome to the ASM Live interview talk show, which we are holding as part of the 2010 General Meeting of the American Society for Microbiology. I'm Jeffrey Fox, the features editor of Microbe, which is the monthly magazine of the Society, and your host for these sessions. I'm talking with microbiologists, many of whom are presenting their research during the meeting, and some of them are sharing their hypotheses with us. You, the viewers out there in the electronic village, have an opportunity to submit questions. Those of you who are using Ustream, please submit the questions by the chat room. And for those of you in the live audience here, we ask that you, if you have a question, raise your hand. Someone will bring you a microphone, and then when you ask your question, please identify yourself by name and affiliation. For this session, I'm talking with Arturo Casadevall, who is a professor at the Albert Einstein College of Medicine in the Bronx, New York. And Arturo has recently published a rather provocative paper in a new journal that the ASM is beginning to publish. And we are going to talk in part about the new journal and also to explore this hypothesis. So Arturo, if you would begin by giving us a summary of your hypothesis, and we can talk about it for a while, invite questions from the audience, and then we'll talk some about the new journal and what your aims are as the editor.
As you know, we may be experiencing climate warming in the coming century. There is pretty good evidence that the Earth has warmed already significantly, and this may continue. There has already been suggestions that there are going to be changes in infectious diseases as areas become warmer, that some, for example, vectors may move into them, mosquitoes and things like that. But what we are proposing is that there are going to be new diseases which are currently unknown that will arise as a consequence of global warming. And the hypothesis goes like this. And it is a fact that fungal diseases are relatively rare in mammals. And last year we published an article in which we try to explore why is this so. And in that, what we did was we looked at the thermal susceptibility of about 5,000 fungal species. And what we found is that the majority cannot grow at mammalian temperatures. So you are protected from these fungal pathogens by the fact that you're so hot. So think about what's going to happen now. As the planet becomes warmer, a lot of these organisms will adapt themselves to the hotter environment. And the gradient that separates you from the environment, the thermal gradient, becomes smaller. So as that happens, some of these organisms, once they acquire the capacity for living at 37 degrees, are potential threats to mammals.
Well, it's good to have something new to worry about, as if
we don't have enough to worry about.
Yeah, that's right. But it's really a provocative idea. I guess the first question that comes to mind is how do you test this? Is it right to test this? Can you move some fungal species into a warmer environment? And
we are trying to do experiments like that in a controlled fashion in the laboratory. I would say that my co-author in this study was Monica Garcia Solace, and what she has taken is there is a family of fungi called the Cryptococci, and it includes only one or two that are real pathogenic for humans, and a large number that are not. And many of these that are not is because they cannot grow at 37 degrees. Often they miss 37 degrees by only a few degrees. So,
What do you mean they miss?
for example,
stop growing?
They can grow to 34. They can grow to 35. So the gap between them and your temperature may be 2-3 degrees. So it is known that you can take fungal species and slowly adapt them to higher temperature. What you do is you put them in conditions in which you raise the temperature slowly. And what you do is you select for variants that can grow a higher temperature. If that is the case, you could imagine that some of these organisms can acquire the capacity for pathogenicity. And obviously, that would be very interesting because it would mean that there is an enormous, I would add that fungi are the most successful kingdom. There are 1.5 million species out there, yet the number of human pathogens is relatively few. Only about 150 species have been shown to be pathogenic for humans, and of these, only about 10 are common. The rest are case reports. In contrast, fungi are the major pathogens of plants, insects, and organisms that don't maintain temperature. So the scary idea would be that this enormous kingdom would then become more thermal adapted, and that then it has the capacity to pose a greater threats to both us as well as the mammals that we depend on.
I wonder, are there any examples of fungal species that you find, say, in the tropics where the ambient temperatures are warmer and that fit this description of what might happen in what we think of as more temperate climes?
There are more fungal diseases as you approach the equator. And as you presumably, it could be that they're thermally adapted, so you just have a larger number of potential organisms that could then grow in your body. I would point out to you that prior to the 20th century, to give you a sense of how resistant we are to fungi, prior to the 20th century, most fungal diseases were unknown. You can get in the skin infections, but the skin is cool. It's only when modern medicine began to change the host, that is, with antibiotics, with steroids, with invasive surgery, so we began to see the problem of many fungal diseases.
Now, I'm curious, are there any mammalian species whose normal temperature is lower than ours that would be?
Absolutely. So it turns out that mammals come in gradations of, that is, I don't want to use the word primitiveness, but one way to think about it, for example, the platypus and some of the mammals that sort of lay eggs are much lower in temperature. Now, this has not been studied carefully because people have not gone out there and documented the majority of fungal diseases of these animals. But when you go to the literature and you look, you find that, in fact, they're susceptible to fungi, naturally susceptible. Some of the species are, raising the specter that they don't have the protection that we have.
And in other respects, they have intact immune
systems, right?
So the barrier is the difference in their temperature.
It could be. I mean, it goes with the hypothesis. I wouldn't be. It's consistent with the hypothesis. I wouldn't go. I would tell you that we have the provocative hypothesis that mammals are here because of the fungi. So, because to some degree, mammals don't make a lot of sense. I mean, how many times you eat today?
I have eaten under duress twice today.
Twice. So most of the food you're eating, it just goes to maintain body temperature. A little bit goes to walk around the convention center.
I wish more of mine went to body temperature instead of body fat.
But the point is that mammals are essentially, they consume lots of food. They are very hot. We're very hot relative to the temperature. And we have low reproductive rates, for example, compared to an insect. And the question is...
I have been compared to an insect on that level, yes.
And the question is, how do we get here? So one provocative hypothesis that we have been proposing, and in fact, I'm going to discuss it tomorrow in the Symposium on Extinction, is that after the event that knocked off the dinosaurs, The question becomes, why don't the reptiles come back and reclaim the world? It was the age of the reptiles, but they don't come back. Instead, what you have is the great mammalian radiation. Mammals become the predominant landforms. And that always kind of bothers me because the reptiles survived and they should have been able to take it. So it turns out that there is a fossil evidence that the Earth was a compost then. A great compost, because all these trees came down. And what happens when you have dead vegetable matter? Fungi proliferate. So it could have been that massive fungal proliferation after whatever that very bad day 65 million years ago provided a filter that where the small mammals had a selective advantage. And that's why you're so hot. And that's why you have to eat so much. You know, a crocodile only has to eat once a week.
There's a lesson in there for me, I'm sure, but I'm not sure I want to imitate crocodiles. I do like my meals. The idea, it is a fascinating idea. Can we put some, what other ways are there to put some data behind what's going on? I'm particularly intrigued by the idea that that new diseases seem to come from animals into humans, right. Zoonoses, where so can you think through that for me of how fungi would play into that pattern?
So the big difference between zoonoses and most fungal diseases is that fungal diseases like aspergillosis, coccidiomycosis, cryptococcosis are acquired directly from the environment. Whereas the diseases that we get from other hosts, are, especially if they're mammals, those organisms are already temperature acclimated. So if you were to pick up something, for example, from your dog, it's not making a temperature jump.
Right, because the dog and I are at
roughly the same temperature.
But before, or a little bit earlier, we were talking about mammalian hosts whose temperatures are a few degrees lower. Right. So would that be the likely pathway where the adaptation of the fungus would...
I see what you're thinking. So what I can paraphrase what you're thinking is that the fungi, these potentially pathogenic organisms, will go through a graded series of hosts to reach 37. I think that's very interesting. It can be ruled out, and I not really thought through, but I think a lot of that will depend on the density of those, of such mammals. Most of the mammals around us are pretty hot, like cows and dogs.
Oh, okay, so again, it could depend on where in the globe, also because of the relative temperatures of the fungi in the tropics and that sort of thing. All right. One other question I had that had occurred to me when I was thinking about our discussion, the people who are looking at the bee colony collapse are beginning to say that there may be a combination of organisms, of pathogens working in synergy. And I was wondering whether you would think through, have you thought through how viruses and fungi, for example, might collaborate as the temperature of the globe shifts upward? Would that prime this process, or?
I think there is a very good possibility. I mean, one of the things we often do is we try to assign one cause to things, and yet we know that in the world everything is multi-causal. If you were to get more, for example, viral diseases, which may happen as a result also of spread of changes in global patterns, you could imagine that it is well known that people who get viral diseases can become somewhat immunosuppressed, and that could contribute to that happening. So I think that absolutely it is possible that we may be dealing with multiple hits.
Okay, all right. Now I want to pause for a second and see whether we have any questions coming from the audience. either the electronic audience or the live audience here in the room. And we're seeing no questions. All right, so, oh, you do have a question. We do have a question here in the audience.
The thing with global warming is that basically...
Would you please tell us who you are?
Web, yes. Deborah McKenzie, New Scientist. Basically, it's not that all of a sudden the Earth is going to be hotter than it's ever been. It's that places that are an average temperature of 20 now are going to be an average temperature of 22 then.
That's right.
Why would that cause fungi to suddenly adapt? They've had lots of warm-blooded mammals around to adapt to for all these millennia, and they haven't. And they've had plenty of parts of the planet that are as warm now as certain other parts of the planet will be once global warming takes effect. So it's a matter of a change in weather patterns rather than exposing fungi to conditions they've never seen before.
I think that's a very good point. If I can paraphrase it, the challenge is that there are already hot places, and as I pointed out, that in the tropics there appear to be more fungal diseases. So at least they're consistent with it. But the question says, well, if you're just going to change the average of the Earth, why are we not seeing that already? And what I would say is that when you change the average of the Earth, what you're really changing is you're changing the probability of that happening. You're going to have more places that are hotter. So, and I think that these things are stochastic, that they happen at a certain rate, and if you just increase the probability, then you're more likely to see them. But I think that's a very, very good question.
All right, we have only a few minutes left, Arturo, and I think we ought to spend a bit of time talking about this new journal. Yes. And what its contents will be and how it's going to take shape. Is it going to have as much controversy in all the papers as you're putting into this first one of your own, or what's the balance? What kind of contents?
So this is the first open access journal for the American Society of Microbiology.
And you want to name it for us officially?
mBio.
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 Okay.
People say to me, what does mBio means? And I wrote an editorial that is a made-up word, that in one hand it doesn't mean anything, on the other hand it can mean anything you see into it. For example, mBio is the short abbreviation for microbiology in many courses, and it's also a word that is used in Africa for struggle. And since microbes are always in struggle, you can look into it any way you want.
All right, so the name is provocative.
The name is provocative in itself. I would say that the person who came up with the name was Tom Schenk, and he gets credit with naming it.
Okay.
So it's the first open access journal of our society. It's going to be a vehicle for experimenting to see how we're going to get into the open access era and can we make it work. The journal is interested in really important science, things that are interesting, science that is very well done, science that rises to the very top. And if you look at the first issue, you see that for the first time we have primary data papers dealing with vaccines, viruses, fungi, parasites, basic molecular biology, all under one tent. And that's really new for society.
Okay, so most of the papers will be original research.
That's right.
And then some fraction will be reviews or hypothetical.
Right.
Okay.
We are very interested in hypotheses and ideas. One of the things that unfortunately, from my point of view, is that science publishing has become very formulaic. You know, you go journal to journal and you find that things look pretty much the same. There doesn't seem to be as much room for thought. That is, and if it's well-reasoned thought, we welcome it.
Okay. Well, that sounds like a pretty valuable newcomer to the block.
Thank you.
All right. Well, I think we're about ready to wrap up. I've been talking with Arturo Casadevall of Albert Einstein College of Medicine. I'm Jeffrey Fox. We're at the 2010 American Society for Microbiology General Meeting. Thanks for watching.
Thank you. Thank you, Jeff.